So I'm going to quickly go through the small little covariance averaging chart we had y'all do on the open-ended portion of things. So obviously you set up your chart, you go oldest to youngest. If you did F then A, that's perfectly fine because they're probably the same age. But L is definitely older than O, so the correct order should be CAFLO or CFALO. And that's super important because you'll use values from older animals for the younger animals and so on. So let's remember for an animal in itself, so the covariance of C with C, we have 1 plus the inbreeding coefficient of C. We don't know anything about C's parents, so we're going to assume that C is not inbred. So the inbreeding coefficient of C is 0. So this value right here is going to be 1 plus 0. Moving on to the covariance of C with A. Remember, an older animal with the younger animal is half the covariance of the older animal with the younger animal's parents. So half times the covariance of C with C, because C is A's parent, plus the covariance of C with question mark. We don't know A's other parent, so that value is going to be 0. But the covariance of C with C, which we just calculated, is going to be 1. So it's going to be a half times 1 plus 0 is a half. Covariance with C with F is going to look very, very similar. We have the covariance of C with itself because C is F's parent, and the covariance of C with question mark, we don't know F's other parent. So it's going to be a half times 1 plus 0 is a half. And that goes right here. So far we have these three values. The covariance of C with L, so we go and look at L's parents. L's parents are F and A. So the covariance of C with L is going to be half times the covariance of C and F, and plus the covariance of C and A. And we already calculated those to be a half and a half. So a half times a half plus a half is in fact a half. So that goes right here. And then lastly, for our C column, we have the covariance of C with O. O's parents are F and L. So we have the covariance of C with F plus the covariance of C with L, which we have calculated right here. So it's a half times a half plus a half is equal to a half. And once again, that just translates over up to there. And so we can move on to our A or your F column. Whichever one you did first, you'll get the same thing. So the covariance of A with itself, I don't have it written out, but since we don't know A's sire, we can't know if she's inbred or not, so we assume that she's not. So her inbreeding coefficient is going to be 0, so it's going to be 1 plus 0, which is why this is 1. She's not inbred. And I'll go ahead and say that for F as well. F is not inbred, so we know that the diagonal for non-inbred animals is always going to be 1. So let's carry on to A and F. The covariance of A and F is half the covariance of A and C plus A and question mark because C is F's parent, but we don't know F's other parent. So A and C we already have calculated. We had that calculated right here. So it's going to be a half times a half plus 0 equals a quarter. So the covariance between A and F is a quarter, and that makes sense because in this case they are half sibs. Moving on to A and L. So let's look at L's parents. We know L's parents are F and A. So the covariance of A and L is going to be half the covariance of A with itself plus the covariance of A and F. So A with itself is 1 and A and F is 0.25. So 1 plus 0.25 times a half is 0.625, which goes right there. And then lastly for this column is A and O. Let's look at O's parents. O's parents are F and L. So the covariance between A and O is going to be half the covariance of A and L plus the covariance of A and F. A and L we just calculated to be 0.625, and A and F we calculated to be 0.25. So a half times 0.25 plus 0.625 is 0.4375. So we are done with that column, and we can move on to our F column. We already went over why this is 1, so all we have is F and L, the covariance between F and L. L's parents are A and F. So the covariance between F and L is going to be half the covariance F with itself, plus the covariance of F with A, which is the same as a half times 1, because the covariance of F with F is 1, plus a quarter because the covariance of F with A is a quarter, and that is equal to 0.625, which is right here. It's also the same as 5/8, that's why I have that written there. And then last in that column is F with O. Let's look at O's parents. O's parents is F and L. So the covariance between F and O is going to be half the covariance of F with itself and F and L, which is half times 1 plus 0.625, which we had just calculated, which is equal to 0.8125. And then our L column, we have L with itself. Let's just look at L real quick. Is L going to be inbred? Is his parents related? Are F and A related? Yes. So we know this value is not going to be 1. So let's go to the next page here. The covariance of an animal with itself, or L with L, is 1 plus the animal's inbreeding coefficient, so 1 plus F of L. F of L is equal to half the covariance of L's parents, which we just established were F and A. We can go back to our chart, and the covariance between F and A is a quarter. So we plug that in right here. So we know the inbreeding coefficient of F and L is 1/8. So we go ahead and plug that in back up here. So the covariance of L with itself is 1 plus 1/8, which is 9/8. And so that goes right here. And the last one is L and O. Let's look at O's parents are L and F. So L and O is going to be half the covariance of L with itself plus the covariance of L and F. We just calculated the covariance of L with itself to be 9/8, and if we go back to our chart for L and F, we know that is 0.625, which and we multiply that by half, so that's the answer is 0.875, which goes right here. And then the last thing that we have to do is the covariance of O with itself. And we know that this value is not going to be 1 because O is definitely inbred. F and L are definitely related to each other. So if we go, the covariance of O with itself is going to be 1 plus F of O. And F of O is equal to half the covariance between his parents, which are F and L, which we have calculated to be right here. And so half the covariance of F and L, so half plus times 1.625 plus 1 is equal to 1.325. So that is the covariance between O and itself. You can't forget to multiply by this half or add to 1. It's really important. So that will complete our covariance chart.